Okay, so in this video, I am going to be talking about solving problems with part average testing. This is also known as PAT, and I'm going to be specifically solving this about chip design because it connects to chip design. So I'll discuss a little bit later in the video what part average testing is and the problems with it, and then I'll discuss some possible solutions to it. But first, I'd like to discuss the images here on this um, screen here. So here on the left side of the screen, there's an image, and it's showing part average testing, and it says defects. It shows where there are defects in the chip design, and high false fails. So this would be something like, fails, but not necessarily defects. So it's a little bit better than defects. Defects is the worst, and just the fails. It's like an image showing how chips are tested. This here on the bottom right side of the screen, there's another image. It's an image of the wafer here on the very right side. It has different data and some statistics, what looks like a normal distribution here. So yeah, that's that. So first I'll discuss how PAT works. So PAT, it's a test that is performed on chips. It's used to find if chips are failing, if they have any defects, it's used to also check if they're functioning properly, the components in the chips are functioning properly, all of that. And this is, PAT is a very statistics-based test. It involves a lot of statistics, and specifically, it involves finding the average of various components in the chips. It also involves finding the average of how they function compared to other devices in the chip. Now, a key problem in this method, PAT, is that sometimes PAT can make some major mistakes, and this leads to chips failing a lot quicker than it was supposed to happen. So here there's an image of how PAT works. There's the PAT limit, and there are the outliers, lower outliers, and upper outliers. Here's a more complex image where there's one wafer and a second wafer. There are the outliers of each, and there's the lower limit and upper limit. So now I'll dive deeper into the problems with PAT. So there are a few problems with PAT, but they all pretty much lead to the same result, same outcome. And that is that there are inaccurate estimations, and this leads to the chips failing. So one problem, for example, is that PAT assumes, on its own, it assumes normal distribution of data. However, this is not always the case. Sometimes the distribution of data can be binomial or uniform. And if since PAT assumes normal distribution, it performs normal distribution calculations, and this results in an inaccurate interpretation. It's a mistake that was made. So that's one issue. Another issue is that certain situations, PAT, it can't properly perform a test. And the reason for this is because there are certain complexities in the chips. That would be things like issues with the interconnect or the wafers not working correctly, things like that. And because of this, PAT can't really perform the test properly, and this also leads to mistakes. So now I'll discuss some solutions to these issues. So as you can see here, it says the ultimate solution to these issues in PAT testing is to integrate AI into the software. So now I'll discuss this in more detail. So it's simply as it sounds. You integrate AI into PAT, and you get AI PAT with an AI software. So when PAT has AI integrated in it, and also there are different models of AI, more complex, less complex, all of that. You know, they can perform different calculations and stuff at different levels faster and more accurately. You see, Pat with AI can handle more complex situations than traditional Pat. You see, AI Pat can do a lot more things that Pat on its own cannot, such as it can find distributions that are not Gaussians. You know, it can do binomial distributions, uniform distributions, stuff like that, other than normal distributions. It can also perform more accurate calculations because it has AI in it, and AI can look at the data and analyze it a lot better, can identify outliers quicker and easier. So the solution is to integrate AI into PAT. This way, PAT becomes a lot more efficient, faster, and more accurate. So that's it for this video. Also, here on the bottom of the screen, there's an image showing it says determining dynamic PAT limits, and it mentions how limits in PAT how limits are found in PAT. So, as you know, we've discussed earlier, right here, in how PAT works, that there's like the PAT limit here and stuff. So here's specifically how that's, you know, how these limits are determined. So there's basically two sets, and there's one set here on at first there's one set. If it's a pass, then it goes to the next test. Basically, it goes to the accumulate test data, goes here, and it goes to the second. It goes to the dynamic path test, and if that's a pass, then the limit was found. If it's a fail in the first place, like in the first test, there's a fail, and it goes to this part called the lot trick. Lot. It's called the lot test completed, and if that also fails, then the cycle restarts. But if it continues, then it goes on to the second step, and this could eventually also turn into a pass as well. So that's it for this video. I hope you enjoyed, and if you did, make sure to leave a like and subscribe. That's it for this video. See you in the next video.